Now, I'm about to close, but I want to mention other fusion projects going on because sometimes we get questions about that. First of all, there are other ways to do fusion. There is inertial confusion, which is inertial fusion. That was a slip. Inertial fusion is something that uses lasers to produce a very concentrated burst of fusion at a defined point. There is a combination project that's kind of a mix between magnetic confinement fusion and inertial fusion that's being done by General Fusion, which just announced they're going to build a plant in the UK. In the world of magnetic confinement fusion, you have generally tokamaks and stellarators. ITER is a tokamak, and the tokamak has the most research of any of these models. That's why any of these approaches, that's why it's been so heavily researched. That's why ITER is a tokamak, because it represents probably the most reliable, well-studied way to producing commercial fusion. The largest fusion plant I mentioned before, you saw an illustration of it, is JET. There is an MIT spinoff that is looking at, for the Massachusetts Institute of Technology, that is a private venture. This is also a private venture, Tokamak Energy in the United Kingdom. These are private projects, and people always ask, are they going to make you obsolete? Are they going to go faster than ITER? And the answer is sure. Private investment, private initiatives don't have some of the restrictions that public funding does if you look at procedural things. But from a physics perspective, they've got the same challenges that we do. And it can be, if you're a private investor, it can be a competition, but we don't view this as a competition. We are all working globally, private sector now entering the race, which is a fabulous sign, saying we're getting closer. We are all working to exactly the same goal, to try to address this generational issue that I mentioned at the beginning, the need for massive carbon-free energy. So from the standpoint of governments, ITER will be followed by DEMO, a pilot fusion plant. You've got some ITER members that have announced plans or in some cases are well along toward the conceptual design or the engineering design for their own pilot plants. And as I mentioned in the previous slide, private industry is beginning to invest in fusion energy initiatives. So that's it. Thank you for your attention. I give you this final photoshopped photo that shows that ITER, as building a star on Earth, is taking its place here in the Milky Way among the stars of the universe. If you would like to take an extended tour of the ITER worksite from just a couple of weeks ago, there's a video that will actually take you into some more detail inside the buildings that I was showing. I hope that I've provided you a good introduction to the overall ITER project. And we invite you also to sign up for visits. There's a visit, if you come here to Cadarache, to the south of France, we will do our best to introduce you physically to the ITER project. You get to see it at scale. We also have virtual visits available. We hope that you will continue to follow our project as we really seek to make a complete difference in how energy is produced by future generation in a way that really makes a contribution to carbon-free energy for our children and future generations. Thanks so much.